Good. Okay. So for this part of the demonstration, we have taken off the copter part of the system to show how the input from some user input works, because when it's all together there's a little too much friction for this thing to actually turn, so it's better to demonstrate it with it just, I mean, this is just some wire. Josh is graciously holding it and hopefully it'll rotate about this axis. So I'll show that with this potentiometer giving an input to the microcontroller that will shift back and forth, so hopefully we'll be able to see that in the video. So this pitch we've given a negative orientation. You can see that it's slightly moving and it's pitched this way. And I'll try to get it back to 0. And it should, I'm turning it real slow. It should go the other way. There we go. So we've got it mapped to about plus or minus 10 degrees. And now we'll put it back on there and you can see it in action.
Alright.
Cut.
Fall
Good?
is ready.
Alright.
We got it
Okay, I think
mounted.
we finally got it. We put her on there. I'm going to use this potentiometer again. Keeping it close so you'll see me kind of do some maneuvering here. But I'm going to change the pitch. We give inputs of pitch, or whatever you want to call this. I'm going to call it pitch. It may be yaw or some other word, but it's pitch right now. So I'm going to try to turn it. You'll see it rotate. I'm hoping it'll take off here. Okay, there she goes. Maybe kind of close to that over there. There.
It's a very crude design.
It's perfect. Okay, so I'm going to do a little more, try to speed it up. I'm going to go the other way. I'm going to go the other way. Alright, let's see if it turned around. I went the wrong way. Alright, now I'm going to speed it up in that orientation. Whoa. So that was a little, because of some of that friction, it kind of...
Non-linear effects.
Non-linear, exactly.
Yeah.
It's getting kind of fast here, so I'm going to try to slow it down. Oh, physically, I guess. So it should turn around. So there's a lot of inertia in this system. So sometimes it's hard to judge what it is.
Let's look at the code. What is it outputting? So you're like 0, around 0? No, you're going. All right, there you go. Is that what you wanted?
Yeah, so we get it's the potentiometer has set it to -1 degrees, so it's happy that it's there already, but it's not going to try to change that. That's not going to give us any rotational speed.
Okay.
But if we can look at the code, show you kind of the algorithm. So we have our initial parameters. It's a PID controller. I'm just going to breeze through it. We're not going to actually look at it. I'm just tell you about it. And it gets input for the feedback from the gyrometer that's mounted between the rotors. And you can update the set point from digitally from a serial input, or like we're doing from the
Potentiometer. Analog input, yeah.
And that's basically it. Once it does that, it updates a difference between the duty cycle of the control wire sent to the fans, and that's how it changes the speeds.
Yeah.
So what I can do is show you when error is applied to the system. So if I apply this error, you can, I know it might not be easy to see it on the video, but I can hear it.
You can see the bottom fan.
That this fan is spinning much faster. You can hear that versus this. And then here, you can hear it kind of change. Second. Now this is much slower. Now this was much faster. It's trying to level itself out. And I'll let it, and it'll go back and forth until it finds a steady space.
Steady space.
Look.
Steady location.
All right, and then once it is happy where it is, it's just gonna do that.
Yeah. Ideally, we can get the outputs of this sensor and put into a serial monitor like in MATLAB, but we don't have that working yet. Or that could be a future project.
Right.
Getting
That's moving forward, right? We're helping develop next year's project to be much better.
You having fun over there, Paul?
Oh yeah, this is fun. Okay, that's all. It actually worked.